it's about chemical kinetics, where we had 2 moles of air reacting with 2 moles of B to produce C and 2 moles of D. And we've been given concentrations of air for the first trial experiment and for the second trial experiment. For the first trial experiment, it requires to be filled at the value of 30. So the first question we have to ask ourselves is, what is the order of this reaction? It has been established that for first order reaction, ln, or the logarithm of the concentration of air when plotted with time, will give a straight line, while for the second order reaction, the linear function will be given by plotting the inverse of the concentration of air with time. Okay, so we can use the data in this table to determine which one of these gives us a linear function. So I used the data from the table to calculate the ln of A, and clearly if we plot these values, the values of ln A against time, we will get a linear function. So it's safe to conclude that this is a first order reaction. And by the way, it's not even a must that you plot this graph to determine if these values give a linear function. You can just try to calculate the gradient between this first point and the second point and compare the value with this third point and the fourth one. So if it gives a constant, then definitely that is a linear function, but otherwise if it doesn't give a constant, it's not a linear function. So with this information, we are ready to answer the second part of the question, which asks us to write down the equation for this reaction. So for a second order reaction, ln A will be equal to negative K multiplied by T, then we add ln A naught. This is the integrated equation. So ln A naught is the initial from the table. We determined that it's negative 4.606, and negative K is the slope. So we go ahead and find the slope. Where we can get that by changing getting the change in ln A at 2 different points and dividing that by change in time from our table. So once we have that, you can see that our ln of A is negative 4.606 and negative of K, the slope, is 0.0693. So we just plug in this general equation. Okay, moving to part B, it's asking to solve for K. Now, because negative K is the gradient we get first of negative K, then we multiply this by negative 1 to obtain now positive K. And because K is kind of a ratio, a comparison, it has no units. So for this last part C, where we have to calculate the value of A naught at T is equal to 30 for experiment 1, we go back to our integrated equation, the one that we just determined, that ln A is equal to negative 0.0693 T subtract 4.606. Now we substitute T is equal to 30 in this equation, and we have ln A is negative 0.0693 multiplied by 30, and we subtract all that by from 4.605. Okay, so the right hand side will simplify to negative 6.684. So ln A is negative 6.684. So to get A, we get the exponent, we power it by negative 6.684, and that gives us the concentration of air, which is 1.2508 times 10 to the power of -3 molar, which makes sense.